Metal halide and mercury vapor lamps cannot be directly interchanged. Although the wattages and output voltages may be the same, the lamp designs and spectral outputs are different. Interchanging them can lead to poor performance, reduced light output, and potential electrical hazards. Mercury vapor or metal halide lamps can be used in high-pressure sodium ballast if firstly the wattages and voltages match, and secondly the igniter is disconnected, as mercury vapor and metal halide lamps do not require one. However, note that the secondary voltages of mercury vapor and metal halide ballasts may differ from high-pressure sodium ballasts. It's recommended to consult the fixture and ballast manufacturers for compatibility before attempting this. Clear high-intensity discharge lamps have clear glass envelopes that allow for maximum light output, whereas coated high-intensity discharge lamps have a coating on the inside of the envelope that reduces glare and improves color rendition. Clear lamps are typically used for exterior lighting where visibility is more important than glare reduction. Coated lamps are typically used for interior lighting where glare control and color accuracy are desired. Metal halide lamps can blow or break apart in enclosed fixtures if firstly, the lamps are not rated for the specific fixture type. Secondly, the fixture is not properly ventilated or designed to handle the heat generated by the lamp. And thirdly, the lamp is old or defective. It's important to use lamps specifically designed for enclosed fixtures to ensure safety and prevent ruptures. Bargain-priced lamps may not be manufactured to the same standards as high-quality lamps and may be more prone to breakage. When dealing with electrical lighting systems, particularly high-intensity discharge or HID systems, it's vital to understand the nuances of lamp interchangeability, fixture compatibility, and safety considerations. Improperly interchanging lamps or using mismatched components can lead to reduced performance, equipment damage, or even hazardous situations. Considering the interchangeability between metal halide and mercury vapor lamps, while they might appear similar in terms of wattage and possibly even voltage, their underlying operating principles and spectral characteristics differ significantly. A mercury vapor lamp operates based on the excitation of mercury vapor within a glass envelope, producing a characteristic bluish-green light. In contrast, a metal halide lamp incorporates additional metal halides within the arc tube to enhance light output, improve color rendering, and increase efficacy. These metal halides, when vaporized in the arc stream, contribute to a broader spectrum of light, resulting in a whiter and more natural appearance compared to mercury vapor lamps. Directly swapping a metal halide lamp into a mercury vapor fixture, or vice versa, can create problems. The ballast, which is designed to provide the correct starting and operating voltage and current for a specific lamp type, may not be compatible with the substitute lamp. This can lead to inefficient operation, reduced lamp life, and even ballast failure. Furthermore, the spectral output of the mismatched lamp may not be suitable for the intended application, resulting in poor color rendering and diminished visual clarity. When considering the use of mercury vapor or metal halide lamps in high-pressure sodium fixtures, a few factors must be taken into account. High-pressure sodium lamps operate on a different principle, utilizing sodium vapor under high pressure to generate a yellowish-orange light. High-pressure sodium ballasts are specifically designed to provide the high-voltage pulses required to ignite and sustain the arc and high-pressure sodium lamps. Mercury vapor and metal halide lamps do not require an igniter, but they do need a ballast that can deliver the appropriate operating voltage and current. It's essential to disconnect the igniter circuit in the high-pressure sodium ballast when using mercury vapor or metal halide lamps. The igniter can generate high-voltage spikes that could damage the substitute lamp or the ballast itself. However, even with the igniter disconnected, the electrical characteristics of high-pressure sodium ballast may not be ideally matched to mercury vapor or metal halide lamps. The secondary voltage of the high-pressure sodium ballast may differ from the voltage requirements of the mercury vapor or metal halide lamp, leading to inefficient operation or premature lamp failure. It is always recommended to consult the fixture and ballast manufacturers to confirm compatibility before attempting such an interchange. This ensures that the electrical parameters are properly matched and that the lamp and ballast will operate safely and reliably. The choice between clear and coated high-intensity discharge lamps depends on the specific lighting application and the desired visual effect. Clear high-intensity discharge lamps feature a transparent glass envelope that allows for maximum light transmission. This results in a high level of light output and good visibility, making clear lamps suitable for outdoor lighting applications such as street lighting, parking lots, and security lighting. However, clear high-intensity discharge lamps can also produce a significant amount of glare, which can be uncomfortable or even hazardous in certain situations. Coated high-intensity discharge lamps have a layer of diffusing material applied to the inside of the glass envelope. This coating scatters the light, reducing glare and creating a softer, more uniform illumination. Coated high-intensity discharge lamps are often used in indoor lighting applications such as retail stores, offices, and warehouses, where glare control and visual comfort are important. The coating also improves color rendition by diffusing the light and reducing the prominence of individual spectral colors. Metal halide lamps can sometimes experience breakage or rupture, especially in enclosed fixtures. Several factors can contribute to this phenomenon. Firstly, the lamp itself may be defective or nearing the end of its rated life. As metal halide lamps age, the arc tube can weaken and become more susceptible to thermal stress. Secondly, the fixture may not be properly designed or ventilated to dissipate the heat generated by the lamp. Enclosed fixtures can trap heat, causing the lamp to overheat and potentially rupture. Thirdly, the lamp may not be rated for use in enclosed fixtures. Some metal halide lamps are specifically designed for open fixtures and may not be able to withstand the higher temperatures and pressures encountered in enclosed fixtures. It's important to use lamps that are specifically rated for the intended fixture type to prevent breakage and ensure safe operation. In open fixtures, it is recommended to use open-rated lamps that are designed to withstand the elements and operate safely without an enclosure. Using bargain-priced lamps can also increase the risk of breakage, as these lamps may not be manufactured to the same quality standards as high-quality lamps. Low-quality lamps may have thinner arc tubes, less robust construction, and less precise manufacturing tolerances, making them more prone to failure. Always choose reputable lamp brands and purchase lamps from authorized distributors to ensure quality and reliability. When installing or replacing metal halide lamps, always follow the manufacturer's instructions and safety precautions. Wear safety glasses and gloves to protect yourself from potential hazards such as broken glass and electrical shock. Ensure that the fixture is properly grounded and that the lamp is securely installed. Regularly inspect fixtures and lamps for signs of damage or wear, and replace any damaged or worn components promptly. By following these guidelines, you can minimize the risk of lamp breakage and ensure the safe and reliable operation of metal halide lighting systems. Understanding the importance of proper lamp selection, fixture compatibility, and safety measures is crucial for maintaining a well-lit and hazard-free environment. This includes understanding voltage requirements. Typical voltages encountered in lighting systems include 120 volts, 208 volts, 240 volts, 277 volts, and 480 volts. These voltages are common in North America, but other voltages may be used in different parts of the world. It's essential to verify the voltage rating of the lighting equipment and ensure that it matches the available voltage supply. Using the wrong voltage can damage the equipment or create a safety hazard. Ballasts play a crucial role in high-intensity discharge lighting systems, regulating the current and voltage supplied to the lamp. Different types of high-intensity discharge lamps require different types of ballasts. For example, metal halide lamps typically require a different ballast than high-pressure sodium lamps. It's essential to use the correct ballast for the lamp type to ensure proper operation and prevent damage. Ballasts are also available in different voltage ratings to match the available voltage supply. Always select a ballast with the correct voltage rating for the lighting system. Wiring is another critical aspect of electrical systems, and it's essential to use the correct wire size and type for the application. The National Electrical Code or NEC specifies the minimum wire size required for different ampacities. Ampacity is the current carrying capacity of a wire, and it's determined by the wire size, insulation type, and ambient temperature. Using a wire that is too small for the load can cause the wire to overheat, potentially leading to a fire. It's always best to err on the side of caution and use a wire size that is larger than the minimum required. Grounding is an essential safety measure that helps to protect against electrical shock. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and de-energizing the circuit. All electrical equipment should be properly grounded, including lighting fixtures, ballasts, and wiring. Grounding conductors should be connected to a grounding electrode system, such as a ground rod or a metal water pipe. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Circuit breakers and fuses are rated in amps, and it's essential to use the correct size overcurrent protection device for the circuit. Using a circuit breaker or fuse that is too large can allow excessive current to flow, potentially causing damage or fire. Understanding the proper application of NEC tables is critical for safe and compliant electrical installations. The NEC contains numerous tables that provide guidance on various aspects of electrical wiring, including wire ampacity, conduit fill, and equipment grounding. For example, NEC Table 310.15b16 provides ampacity ratings for various types of conductors based on their size and insulation type. NEC Table 310.16 provides the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius in free air based on ambient air temperatures. NEC Table 310.5 covers underground conductors. It's essential to consult the NEC and other relevant standards to ensure that electrical installations comply with all applicable requirements. Electrical safety is paramount, and it's essential to take precautions to prevent electrical shock and other hazards. Always de-energize circuits before working on them, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Electricity can be dangerous, and it's always best to err on the side of caution. When working with electrical equipment, always follow the manufacturer's instructions and safety guidelines. This includes proper installation, operation, and maintenance procedures. Using electrical equipment improperly can damage the equipment or create a safety hazard. Regularly inspect electrical equipment for signs of damage or wear, and replace any damaged or worn components promptly. Ignoring safety precautions can lead to serious injuries or even death. It's important to take electrical safety seriously and to follow all applicable guidelines and regulations. By doing so, you can protect yourself and others from electrical hazards. High-intensity discharge lighting systems are an integral part of many commercial, industrial, and outdoor lighting applications. By understanding the principles of high-intensity discharge lighting and following proper installation and maintenance procedures, you can ensure that these systems operate safely and efficiently. Always consult with a qualified electrician or lighting professional if you have any questions or concerns about high-intensity discharge lighting systems. Their expertise can help you to select the right equipment for your application and to ensure that the system is installed and maintained properly. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or lighting professional before performing any electrical work or making any changes to a lighting system. Ignoring this advice can lead to serious injuries or property damage. Electrical systems are complex and require specialized knowledge and skills to work on safely.